So today what we're going to do is we're going to study this thing called quadratic relations, okay? Now, here's what I want you to understand. Quadratic relations are nonlinear. The graph is called a parabola, and it has a high point if it opens down, and it has a low point and if it opens up. Now, the one thing that I want you to remember is when we talk about stuff that's opening up and down, we're talking about it looks like this or it looks like this, where this point on the top of the one that's opening down and this point that's at the very bottom is called the vertex. Now, remember, your graph can open up or it can open down. And the rates of change for the graph constantly changes. So if I was actually looking at the slope of this graph here, as I move from left to right, the graph changes its slope until it gets flat, and then it becomes steeper and steeper and more negative and negative. Okay? Now, let's go and talk about how we would get something like that. So, for example, let's take a look at this graph. I'm actually going to create a graph in Desmos for the base graph of y is equal to x squared. And we're going to see what actually is occurring. So in Desmos, we're literally going to create a table. And in the table, we will have two values, the x values and the y values. At the top of the table, you're going to have x sub 1. And for the second half of the table, instead of y, you're going to have x sub 1 squared, i.e., we're just replacing what y is supposed to be when we calculate it. So to create a table, what you do is you click plus and you hit table. And then you tell it what you want in your table. In this case, I want x1. And then for my y, I'm going to change my y to, instead of y, what I have to punch in a number, let's go and type x underscore that creates the sub function, and then you hit 1. And then here's what we're going to do. We're going to put it in a bracket, start it with a bracket, and then we're going to hit the shift 6 to create an exponent and hit squared. So here's what we're going to do. We're going to zoom out in our little chart here, and we're going to zoom out to say 20. All right, so there's our chart. So for y equals x squared, let's go and use the numbers from -4. Notice when I punch in -4 into this bracket, it automatically goes and creates the value of y squared, right? So instead, if I punch in -4, I'd have to put a -4 in a bracket squared, and you get that. So that's so this part here. So this is our first point. So this -416 is our first point. So now let's go and create the rest of the points. So now let's go up by 1. So -3 gets plotted. Yeah, that's good. Now let's go and plot -2. -2. And now that Desmos has a pattern for the x's that we're using, all we have to do is hit enter. And it will go and create the other spots. And now you'll notice what's happening with my graph. My graph is literally swooping down and swooping up. So if I went and graphed my line y is equal to x squared, we have this nice graph here, which I will highlight and then take the points out. So the graph looks like this. And what is crazy about it is that if we were looking at this basic graph, our graph literally goes over 1, up 1, over 1, down 1, stuff like that. So now we'll talk about that as we go through the rest of the lesson. The first thing that we do with a parabola is we usually create a table of values, and we can easily create that using Desmos at any time. Okay, so now we have to talk about what things are in this graph. Right now, we have this beautiful point right here. That beautiful point right there is my vertex. It's the lowest point on my graph, and it's at 0, 0. Okay? Now let's go back to our lesson here. So here's what a quadratic relation looks like on a graph. So if it's opening up, it looks like this. If it's opening down, it looks like this. It doesn't necessarily ever stay on the graph. So technically, you could think of it as if I clicked on here, oh boy, think of it as being able to move up. So I could literally say take this out and then put in another graph. Maybe the graph opens up, but it's above the graph. Or the graph instead, maybe it touches, maybe your graph will just barely touch the x-axis, right? So those parabolas can look like anything like that. Now, based on our table of values, right? Let's go over the table of values that we were studying. So we had the following: x and y, which was equal to x squared, right? So when we punch those in, we got -2 and 4. We had -1 and 0. We had 0 and so 0, 0, 1, 1, 2, 4. So now what we'll do, so now we have our table of values. Based on these table of values, we can do our first differences. All right, so 1 minus 4 gives us -3. And then 0 minus 1 gives us -1. And then 1 minus 0 is 1. And then 4 minus 1 is -3. No, it's +3. So now that we have our first differences, we know that this is supposed to be quadratic. Basically, a quadratic relation looks like those equations that we were working with in the last unit. So what should happen is our second differences should be the same. So we have, for our second differences, we've got the following. We've got 2, 2, and 2. So this is quadratic. Since the, what would you call it? The second differences are the same. So now let's continue with the rest of the work that we have here, okay? So here are some basic equations that we've seen before. You've seen equations like this: x squared, 2x squared plus 5, right? And we had to do something. We either had to factor it or we had to do something else with it. But you know what? A relation means we have y is equal to it. So for any x that we punch into this equation, we can always find a y. Here's another example. Let's call this example 2, and that's example 1. So example 2 is this. Suppose that I have c is equal to -4.9 t squared plus 20. So this represents a ball being thrown into the air at 20 meters per second, and the Earth is pulling it back down. Okay, so how high would it fall? How long would it take to hit the ground? It could tell, that equation could tell me that. Now another equation that looks like a parabola is this: y is equal to 0.5 q squared. Notice this. All have powers of 2. Now I'm going to say a maximum power of exponent 2. Now because they all have this maximum power of exponent 2 here, here, and here, all of these graphs look like points on our parabola here. So let me just show you for an example what these things look like. I'm going to hide these things that we just created, and what we're going to do is I'm going to basically punch in one of those equations. So let's say I have y is equal to 2x squared plus 5. So notice it's a parabola, but the parabola has been moved up, right? We'll explore this later on in this unit. We also have we also have c is equal to negative 4.9 t squared plus 20. Well, look at that. The graph is opening down. I wonder why that is. We'll take a look at that stuff later. Right now, we're going to be taking a look at the work that we're doing in class, i.e. identifying this point on our graph, these key points here and here, okay? And this thing that's right in the middle, I call it the mirror line. The line that, if you look at it, you could split this parabola in two and use that if I graphed one half of my lines and just copied it to the other side, okay? So that is called an axis of symmetry, and we'll talk about it a little later. Now, let's get back to our lesson. So, just like I said, anytime we talk about this, a quadratic or a parabola is identified by the powers of 2 that exist on each of these equations that we have here. Okay, so notice the 2, and the 2. All right, so now my next question for you is, how do we go about graphing this thing? I'm going to give you a basic graph, and then what we're going to do is we're going to investigate things like, I'm going to identify some key things on our graph, and then you will be able to tell me about the attributes of the graph. So now, here's our graph, all right? So remember our basic graph from before. Our basic points from before were x and y is equal to x squared, right? So when we punched those in, we had negative 2, negative 1, 0, 1, and 2, right? And we also had 4, so this was 4, this was 1, 0, 1, and I guess 4 again. So what we're going to do is we're going to take a moment, we're going to plot all those points. So I'm going to plot this point. Now I'm going to look at the differences here. So the first differences here is negative 3, then this one here is negative 1, this one here is, what would you call that, negative 1, and then 3, yeah, and then 3. So this is actually telling me on the right side I'm going to go over 1 and then up 1, over 1 and then up 3 spots. Now, what do you think the next spot would be if I went over 1? How much do you think I would go up for the next one? If you thought it was 5, then you're correct. 1, 2, 3, 4, 5. So, for the equation y is equal to x squared, we have some basic steps we can use to graph our parabola. And those steps are 1, 3, 5. So the key idea is to go over and then up each one of those numbers. So you would go over 1, up 1, over 1, up 3, over 1, up 5. And we end up with our points here. Now, this is awesome. This is great. It means that we have a nice set of points that will allow us to graph half of the parabola. Isn't that great? Now, always put an arrow at the end of the parabola and give our equation y is equal to x squared. Now, imagine you're looking at the concept of this parabola, right? And all I wanted was to be able to graph the other side of it. Essentially, we have this thing, I call it the mirror line. So I'm going to use my highlighter here to kind of highlight it. So the mirror line here is going to be, it's actually the axis of symmetry. We call that, this one is x is equal to 0. So whatever value of x is in that line is what you use for it. So in this case, our axis of symmetry is 0. So now, if I want to be able to graph the rest of this, remember our original parabola that we had here was literally mirrored around the x-axis. If I put in x is equal to 0 here, this red line here, x is equal to 0, we have a beautiful line that shows that we have a mirror line for which we could literally find a matching point on the other side. Now, in our solution here, we have these basic points. So now what we do is we literally just put our points in. So this point here is mirrored here. This point that I'm highlighting here at 4 is mirrored across at 4 here. And then this point here, nice and big, is mirrored across here at this point. So now we can literally graph the other half of our parabola. And that is the cool part of parabolas. If you can get one half of the parabola from the vertex, what this thing is here, the vertex, you can always find the axis of symmetry, and you can find the basic points that will allow us to graph it. Now, in this case, my vertex is 0, 0. But let's say that I had a graph that looked like this. Let's say my parabola was at 6, 8. Okay? And it went down, down 1, down 1 over 1, down 1, over 1, down 3, and then over 1, down 5. And then we have our mirror line. So our vertex, remember, always has a mirror line that goes through it, right? In this case, this mirror line is called the axis of symmetry. And that axis of symmetry is x is equal to, instead of 0 this time, it's x is equal to 6. Now, for the other graphs. So now that I have my mirror line, I can match these points on the other side. So my first point, down 1 over 1, is matched to the other side here. And then this other point at, say, 8, 3 is matched at this point right here, which is 4, 3. And then this point here that I'm highlighting is matched, is just copied to the third spot over, same level. And then we can draw our graph. So the steps for a negative parabola are going to be -3, -1, -3, -5. Now, here's the best part. We'll talk about this later as we go into graphing these things, right? Now, if I was looking at the first graph, the red graph here, the red graph, so this one, okay? What this graph has for me is it has a minimum or a maximum. In this case, we say this one here has a minimum of y is equal to 0. So that is this one. For the second graph, this one here, the blue graph, right? This one is opening down, and because it's opening down, it has a max of y is equal to, if I extend my line across, 6. in that case. So we should be able to identify all these things, right? Now, let's go over examples of real life things in our homework. Now, okay, so now we're going to take a look at some real world examples, okay? So I'm going to look at one picture here, and I'm going to identify the vertex, the axis of symmetry, the intercept, and the y-intercept, and what the maximum or minimum value is. So let's zoom in on the Arc de Triomphe. When I'm looking at the Arc de Triomphe, what we have is something that looks like this, where our x-axis is here. This is our y-axis. Now, this part here on the very top is our vertex. And when you go and talk about the vertex, I always want you to give me the point. Now, I can't see the point here. Maybe it's 0, 200 for 200 feet. And then these values here, I'm going to highlight them in red, put an X in red, are our X-intercepts. Now, if I ever ask you for the X-intercepts, you will have to give me either a point or a simple X value. You could say X equals, say, so for this one, you could say X is equal to, for the X-intercept, 150. And then for this one, it's X is equal to negative 150. Or you could tell me it's the point 150, 0. Right? And then this one was negative 150, 0. You could also tell me what the axis of symmetry is, i.e. the mirror line. The mirror line for this one is X is equal to 0. And the reason why it's X is equal to 0 is because it's the y-axis, right? Okay, so, and remember that our vertex and our axis of symmetry go through each other. So this part here, the 0 in here, always matches the axis of symmetry. Now, if I was looking for the maximum, you would say the max for this one is y is equal to 200. And where did I get that? The reason where I got that is I actually got that from my y portion of the vertex. Okay? And that's it. We've identified everything that we need to know. Oh, and we've also got to identify the y-intercept. The y-intercept in this case is 200 because it crosses the y-axis at 200. Okay? And we're done. Now, I'm going to provide you a copy of this picture to work with. I want you to kind of take a look at those pictures and identify each one of the axes of symmetry, vertex, and things like that. Draw that into the pictures, into some of the pictures, and tell me what the maximum or minimum value is, right? Now, you need to remember certain concepts, right? For the max and min, right? So this one, when my graph looks like this, then we have a max. When our graph looks like this, we have a min. Okay? Now, x-intercepts don't always happen. And this is why. Because sometimes you could have a graph that opens up above the x-axis or opens down and is below the x-axis. But there will always be a y-intercept. All you have to do is just look for that on the graph. Now the vertex, the axis of symmetry is always the mirror, And remember, our vertex is always a point, boom, always a point at the top or the bottom. It's the top of this graph or it's the bottom of this graph. Okay, and that's it. So I'll make sure that you have a copy of this note online. All right? Okay. So here's what we have in summary. So the top or the bottom of a parabola is called the vertex, and I'll just highlight that here. Okay? All right? And in this case, our vertex is at 4, 8. Now, I also talked about the steps of the parabola. So for y is equal to x squared, we would say our steps are, let's say, 1, 3, and 5. So you must go over first, and then go over 1, then go up 1, then go over 1 again from that same point, and then go up 3, then go over 1, and then go up 5 for our points. Now, if I have a graph that looks like y is equal to negative x squared, then instead of having steps of 1, 3, and 5, we're going to have steps of -1, -3, and -5. You can use that later, but not right now. We're going to use Desmos to create most of our graphs. So the other thing that I want you to recognize is that when we talk about the x-intercepts, right? The x-intercepts are these points here, these highlighted yellow points. Those highlighted yellow points are called the x-intercepts. That's where they cross the x-axis. They are also known as roots, okay? Now be very careful. I want you to focus on that. So when we look at x-intercepts, we are also calling them roots from time to time, okay? Now, the y-intercept for this graph is -8, right? And for the point, you would write 0, -8. So that's what this part is right here on my graph, okay? Now, the only thing that I haven't said here is what the maximum is. So because this graph is opening down, we have a maximum of y equals 8. And you'll notice that that maximum comes from the y coordinate in my vertex. Now, the last thing that I need you to recognize is that for every parabola, it always has an axis of symmetry. And that axis of symmetry always goes through the vertex. So you're going to have to kind of work that in your head to kind of make you remember how this stuff works, okay? Now, on your lesson today, you're going to have several graphs that you will look at. All of the graphs will have a vertex, a y-intercept, and possibly x-intercepts. If there aren't any x-intercepts, just say there aren't any. Okay? All right? And that's it for today's work. Get to it.